Hi there, Mr. Sutton here with the Pre-Cal Honors 2-1 Extra Practice Number 1 solutions on solving polynomials by factoring. To solve this problem, first I tried taking out common factors, but it doesn't look like we have any for all four terms. But since there are four terms, I can try to do this one by grouping. For these first two terms, I can factor out an x squared. That leaves me with x plus 6. For the second two terms, I can take out a negative 4, leaving me with an x and a plus 6 there as well. Now I can take out this x plus 6 as a common factor, and I'm left with x squared minus 4 as my other factor. Setting each of these factors equal to 0 in solving, we see that x must equal negative 6 for that first factor, and for the second factor, x squared must have a value of 4 because we want this to come out to 0. So if x squared equals 4, square rooting both sides here, we see that x equals plus or minus square root of 4, so plus or minus 2. On this problem, we can't take out any common factors, but this is quadratic form. We have x to the fourth, x squared, and a constant. So let me try factoring this thing, and I'll just use x squared wherever I would normally use x. So factors of negative 32 that add up to negative 4. Let's see, 1 and 32, no. 2 and 16 is not going to do it. 4 and 8, if I had x squared plus 4 and x squared minus 8, that would add up to negative 4. So let me split it up then. We have x squared plus 4, x squared minus 8. Now we can set each of these factors equal to 0 and solve. So if x squared plus 4 equals 0, that means x squared equals negative 4. Square rooting both sides of that, we can take this negative out as an I. That's going to be plus or minus 2i. And then for this next one, if x squared minus 8 equals 0, that means x squared equals 8, if we add that 8 to the other side. And then square rooting both sides of this, well, I can split my 8 up into radical 4 times radical 2. So then this is going to come out to plus or minus 2 radical 2. For this one, as always, we try taking out a common factor in the beginning. Looks like I can take an x out of all these. So that leaves me with an x squared plus 6x plus 5. And now this quadratic inside here, it looks like I can factor that. So factors of 5 that add up to 6, there's not a whole lot to choose from. We have 1 and 5, and fortunately that works. So I can break this up into, let me bring down that x. We have an x plus 1 and an x plus 5. Setting each of these three factors equal to 0 in solving, we see that for this first x here, x equals 0. Then we have x equals negative 1 and x equals negative 5. On this problem, we can't take out any common factors. However, this is quadratic form. We have x to the fourth, x squared, and a constant. So I'll try factoring this, and I'll just use x squared instead of x. So I need factors of negative 8 that add up to 2. 1 and 8 won't do it, but if we had negative 2 and positive 4, that would do the job. So I can split this up into x squared minus 2 and x squared plus 4. Setting each of these equal to 0 in solving, if x squared minus 2 equals 0, then we can add the 2 and say x squared equals 2. And square rooting both sides, we get x equals plus or minus radical 2. For this next one, this means if x squared plus 4 is 0, that means that x squared must be negative 4. Square rooting both sides of that equation, I can pop that I out because I have a negative inside the radical. Square root of 4 is 2, so this is x equals plus or minus 2i. On this problem, before I do anything else to try to solve this, I'm going to add this 8x to get it over on the left side, and I'll just write in decreasing order of exponents. So we have x cubed plus 6x squared plus 8x equals 0. And as always, I try to take out a common factor before trying anything else, and it works out this time because I can take an x out of each of these. That leaves me with x squared plus 6x plus 8, all of that equaling 0. The quadratic inside this parentheses can be factored. We need factors of 8 that add up to 6. 1 and 8 doesn't work, but 2 and 4 does. So I can break this up after I pull down that x there. I can break this up into x plus 2 and x plus 4. Setting each of these equal to 0 in solving, we have x equals 0 for that first factor, negative 2 for the second factor, and negative 4 for that last factor. On this polynomial, it looks like I can't take out any common factors from everything, but I can take them out, two at a time. Since I have 4 terms here, I'm actually going to try grouping this thing. For the first 2 terms, I do notice that I can take out an x squared. That leaves me with 4x plus 1. And for the last 2 terms, I can take out a 3, leaving me with 4x plus 1. Well, now I can take out that common factor of 4x plus 1, and that leaves me with x squared plus 3 as my other factor. Setting each of these equal to 0 and solving, if 4x plus 1 equals 0, then I can subtract 1 and divide by 4 to get x equals negative 1 over 4. And then for this next one, if x squared plus 3 equals 0, well, that means that x squared equals negative 3, which means if I square root both sides and take out an I, we have x equals plus or minus I radical 3. For this problem, we want to know how many real solutions the equation x to the 4th minus 1 has. Now, by equation, they didn't actually give us an equation. Presumably, we mean x to the 4th minus 1 equals 0. So to solve that equation, what we can do here, since this is actually the difference of perfect squares, we can split it up using the plus minus shortcut by square rooting each of these. So I have x squared plus 1, and then the square root of this thing, x squared minus 1. And all that equals 0. Since I've got this broken down to quadratic factors, I can actually just set each of these equal to 0 and solve on its own terms. If x squared plus 1 equals 0, that means x squared equals negative 1 for this factor here. And square rooting both sides of this, we get x equals plus or minus I. For this next one, if x squared minus 1 equals 0, that means x squared equals positive 1. Square rooting both sides of this, we have x equals plus or minus 1. So they wanted to know how many real solutions we had. These i's don't count as real solutions. Those are imaginary. These 1's count, though. Negative 1 and positive 1 gives us a total of 2 real solutions, giving us choice C.